Okay, thank you for joining again for the lesson. And we are now going to start to discuss our question. Now let's look at our question and check your answer, please. Now here, for the question on this part, we are talking about this, the factor just now. So what is the metal P that you use over there?
Teacher, I used zinc powder.
Okay, anyone else using? Any more friends uses zinc? Okay, the answer, if you are using zinc, you are correct. So how do you express your answer? You may write like this. You can just put metal P is zinc. Okay, now make sure that you are writing in words because they tell you to write, to put the name. Okay, now who can tell me what is the acid Q that you are using? Shall we hear from Vaishnavi? What is the acid Q? Joseph?
HCl, teacher.
Sorry, Vaishnavi, what acid?
HCl. Hydrochloric acid.
Hydrochloric acid. Joseph, are you using hydrochloric acid?
Teacher, if I use magnesium, can?
Okay, now if you are using magnesium, can. Okay. If you use magnesium, you use aluminium, you use zinc, okay. But no using copper, no using lead. Because this is a metal with acid. We have already learned in our chapter about the acid and base and the salt. We have to put reactive metal with acid, okay? Now, for the acid Q, it can be any type of acid, no problem. And from here, you are writing the chemical equation. So let's say for the metal P, you are using zinc. Therefore, now you are writing the zinc plus the HCl. This part, it is totally the same as what you are writing on top here. And you should be getting actually the ZnCl2 plus the hydrogen gas. Okay. Now, don't forget to balance up the equation. Now, when I'm typing, I cannot change this to become the subscript. So you please change it. I cannot change it here. So you please write in the correct manner. Okay. So now, in this case, when you want to balance up the equation, this should be a 2 and any more 2 to put. This is the balanced chemical equation. So with this, you have already get the 4 marks. How to get the 4 marks? I show you. Just now, when you mentioned this one, 1 mark, 1 mark. Okay. Correct reactants and product, 1 mark. Balance, another 1 mark. Okay, now next part. Calculate the average rate of reaction for experiment 1 and experiment 2. Now, from the question, it was said that 30 centimeter cube of hydrogen gas is produced. Therefore, you are writing as experiment 1. Have to label, then you write about the rate of reaction. And we know that when we want to calculate, we have to write the title, rate of reaction equals to what? Change in volume versus the time taken. So the volume which is produced is actually 30 centimeter cube. Now for set 1, we are taking 10 what? Can you see? 10 seconds. So your answer will be actually 3 centimeter cube per second. Okay. Now for experiment 2, your answer should be 2 centimeter cube per second. The same thing. I am using the blue for experiment 2. Experiment 2, this one will change to 20. And the answer will be 2 centimeter cube per second. Okay, next part. Now we are now going to talk about the explanation in the rate of reaction between 1 and 2 using the collision theory. Okay. Now I would like you to tell me what is your answer. Okay. Now we would like to hear from our friend Shalene. First of all, we compare the rate of reaction. So what can you tell about this, Shalene?
Concentration of acid.
No, you compare the rate of reaction first.
Experiment 1 is higher.
Okay, is higher than experiment 2. Okay, next. What will be the next point? Should we hear from Sinru?
The number of hydrogen ion per unit volume in experiment 1 is higher than experiment 2.
Okay. We are now going to talk about the factor first. Okay. After you have compared this comparison sentence, you can put it to the last. You want to put it at first, okay, no problem. That one is comparison. Now, when we want to start to talk about our collision theory, always we are talking about the factor first. So what is the factor, Sinru?
Concentration
Concentration of what?
of hydrogen ion.
Of hydrogen ion or the of the hydrochloric acid? Which one?
Hydrochloric acid.
Yes, should be the hydrochloric acid. In which experiment is higher?
Experiment 1.
Okay. Now, last lesson, we talk about the concentration of hydrogen ion is because we are using two different types of acid, which is the hydrochloric acid and the sulfuric acid. Okay. But today we are using the same type of acid. So we are talking about the concentration of hydrochloric acid. But of course, if you are telling the concentration of hydrogen ion, I cannot say that you are wrong. Why? Because when the concentration of hydrochloric acid increases, the number of hydrogen ion will also increase. Okay. Now, what will be the next sentence? Should we hear from Kaizi?
The frequency collision.
The
frequency collision of the.
Have we mentioned about the keyword? Have we mentioned about the keywords here?
No.
No. So the next step should mention about the
number of particles.
Okay, what particles is it? What particles from the hydrochloric acid which took part in the reaction? Anyone?
Hydrogen ion.
Yes, the number of hydrogen ion. Don't forget the word per unit volume. In experiment 1 is higher than experiment 2. When you are writing, you please write in full. The number of hydrogen ion per unit volume in experiment 1 is higher than experiment 2. Okay. Then only you talk about the frequency of collision. So the frequency of collision. Now I want to know between what and what. Shall we hear from Vernon? Between what and what? What are the particles which collide with each other?
Gas particles, teacher.
What particles?
Gas particles.
Sorry?
Gas particles.
Gas particles, are you sure? Okay, now for those who cannot determine, I'm going to show you what you should be doing to determine the particles that collide with each other. I'm going to write it here. Just now you were having your equation as this. You're having your equation as this one, the ZnCl2 and hydrogen gas. Now from here, if I were to write the ionic equation, I am having the Zn plus 2 mole of hydrogen ion, getting the zinc ion and the hydrogen gas molecule. Agree? Now, therefore, from what we see here, these two are the particles which collide each other, colliding particles. Therefore, when we are talking about this, the frequency of collision between what? It is actually between the zinc atom and hydrogen ion. Okay. In experiment 1 is higher than experiment 2. Okay. I hope you can follow. And the important part here is the part that I put in the box. Now, when you read from some of the books, they say between the particles. Yes, it's correct, between the particles. But we are now answering according to this question here, specific to this question. Therefore, you have to tell what are the particles. And the word atom and hydrogen ion must be there. Atom must be there. Why? Because we know that when we are talking about particles, the type of particles, we are having the atom, the ions, and the molecules. That's why when we are talking about particles, the word atom and the word ion must be there. Okay, now we move on to the next part where we are talking about the last sentence. When there is frequency of collision, there also will be the frequency of effective collision. Okay, between who? Again, it will be between the zinc atom and hydrogen ion. In experiment 1 is higher than experiment 2. Okay? This is the way of writing the collision theory. And the important part is this. Must know how to write the particles. Okay? Now, as conclusion, when we are writing the collision theory, your steps to write will be always follow number 1, the factor. Number 2, the keywords as how I mentioned previously. Number 3, the frequency of collision. And number 4, the frequency of effective collision. Okay? And if the question asks you to compare, then you compare. So this will be our answer for the collision theory. Okay? I hope you are with me. And now we are going to continue with our question. Now the next part of our question, by using the factor temperature, describe an experiment how this factor affects the rate of reaction. You are going to include a labeled diagram in your answer. So when you are talking about the temperature, what experiment that you want to talk about? Okay, you can have a few experiment where number 1, you can use the experiment as what is given, which is the metal. You can put the metal with the acid, okay? And you are heating the acid. You heat this, okay, to different temperature. Another one, you can use instead of the metal, you can use the carbonate, okay, with the acid. Of course, you are heating the acid as well. Or you can use the one with the sodium thiosulfate. With the acid. Then what are you heating? you are heating the Na2S2O3. Okay. Now all the procedure is in your experiment, in your textbook. Now what I want you to know is that when you are asked to describe the experiment, what should you have when you want to describe experiment? Okay, don't forget, when you want to describe experiment, number one, you should have apparatus and materials. Number two, you should have the procedure. Number three, you should have the observations. Or in this case, it will be the tabulation of data, the results. Okay? And here they are asking you how the factor affect. So you have to make a conclusion for this case. And don't forget, they ask you to add in the label diagram. Okay? The diagram will be based on what experiment you're talking about. If you are talking about the metal and the calcium carbonate, you are using the downwards water displacement. If you are using the sodium thiosulfate and the HCl, you are actually drawing the conical flask on the piece of white paper with an X mark. Okay? Now, I want to remind you about the temperature that you can use. Let's say I am using the sodium thiosulfate solution. At first, you are going to use 30 degrees Celsius. You heat the solution to 30 degrees Celsius. Then you are going to repeat your experiment. You repeat the steps using by heating the sodium thiosulfate solution to 35, 40, 45, and 50. Altogether 5 temperatures, and the maximum will be 50, so that you are getting a linear graph. Okay, so this is our question 6. Any problem until here? Do you have any problem until here? If you are okay, you put a like for me. Are you okay? Okay, good. Any problem, Vaishnavi, Joseph, Vernon? Joseph, do you have any problem?
No issue, no issue.
Can you?
Yes,
No problem, huh?
no issue.
Okay, if you have no problem, then we are going to move on to the next question, which is question 7. Okay, everyone look at the question. The next question. Okay, question 7. Knowledge on the factors affecting the rate of reaction is very useful in our daily life. Now state one activity at home, and explain how the knowledge on the factors affecting the rate of reaction is applied in the activity. Okay, so now what can you talk about it? What can you talk about this? What is the home activity that you can relate to the factor about this about the factors that affect the rate of reaction? Can I have some idea from you? Anyone has idea? Fazi, any?
Cooking.
Cooking, okay. What do you want to cook? What do you want to cook? Anyone can help him. He wants to cook now to apply what we have learned. Shalene, can you cook? Shalene, can you help?
No.
Just now we mentioned, what do you want to cook? Cooking curry, chicken curry, what you want to put in? Vaishnavi, cooking chicken curry, what to put in over there? We are going to put in potatoes, okay? So you are going to talk about when you want to cook the potato fast. One activity, you are cooking chicken curry using potatoes. And you are going to cut it into smaller pieces. Why? Because smaller pieces of potatoes have higher or larger total surface area exposed, can absorb more heat, can absorb heat faster and it can be cooked faster. Remember the first thing that I mentioned when I start, I said about the satay and the roasted chicken, okay? Or you say you want to cook chicken chop, so you don't want to put it into big piece, you make it into chicken cutlet, okay? That one also can. I hope you are okay with that, okay? Now, next part. Look at the second part of the question. The question says, the graph of volume of carbon dioxide gas against time is shown to you. Now, can you see there are keywords here? I hope you can identify the keywords. What are the keywords here? Someone? Joseph, what are the keywords here in the question? First line here.
Volume of carbon dioxide gas
Some more?
against time
Some more?
for the reaction between sulfuric acid and excess marble.
This part,
calcium carbonate.
this part, yes, thank you. This part is important. Sulfuric acid and excess marble, or sometimes they call it as the marble chips. Okay, this part. Why I said this part is important? Because later, can you see down here? They ask us to write the chemical equation. Okay, now let's look at the graph. What can you tell about the experiment 1 and experiment 2 based on the rate of reaction? What can you tell about the rate of reaction of experiment 2 compared to experiment 1? Okay, now I hope you get the answer. The rate of reaction of experiment 2 is higher than experiment 1. Okay, and you will find that here the maximum volume of carbon dioxide gas produced by experiment 1 and 2 is actually the same, which is 960 centimeter cube. And the time taken for experiment 1 to get the 960 will be 240 seconds, while for experiment 2, the time taken will be 160 seconds. Okay, I hope you can get this information. Now we move on to the next part of the question. The next part of the question, it says, asking you to write the chemical equation, calculating the rate of reaction, which is the average rate of reaction. Okay, and for part 3, explain the difference in the rate of reaction based on the collision theory. Okay. Now for part 1 and part 2, I think you have no problem, because now for part 2, average rate of reaction, you are going to take the volume, which is 960. For 1, just like I said, it is this one, this graph. So it is taking 240 seconds. Now you are taking the 960 divided by 240. The unit will be in centimeter cube per second. Okay. But now I want to talk about this. The difference in the rate of reaction for experiment 1 and 2 based on the collision theory. Now, what is the factor? Okay. Now, can you see the question here? Here, just now we missed out this part. This part. I'm sorry. Experiment 1 using marble chips. Experiment 2 using marble powder. What can you tell me about the chips and the powder? What is the factor? Anyone who can tell me about the factor?
The size.
Size of what?
The size of the marble.
Yes, it is the size of the marble, or the size of the calcium carbonate. Okay. You don't mention only about the size, you have to mention it specifically. So the factor that affects the rate of reaction in this case, it is actually here the size of calcium carbonate. In experiment 1 is larger compared to experiment 2. Then what will be the keywords? The keywords will be the total surface area exposed, of marble chips or the calcium carbonate in experiment 1 is smaller. When the size is larger, total surface area exposed is smaller compared to experiment 2. Then you talk about the frequency of collision. Okay, now I want to guide you on the frequency of collision. Okay, now I'm going to write it in blue over another side. Now when we are talking about the frequency of collision, I said we have to write about the particles. Now the particles that involve, we are going to write chemical equation where the calcium carbonate react with the sulfuric acid. You are getting calcium sulfate, carbon dioxide, and water. Okay, now we balance up the equation. This equation is balanced. Okay, now next part. In order for us to determine the particles that collide, we are going to write ionic equation. Okay, now this calcium carbonate is a solid, so you write back calcium carbonate. For the sulfuric acid, it is a solution, so you separate it. Okay, now on the next part, on the product part, the calcium sulfate, you put it back. Why? Because it is insoluble. Okay, it is insoluble. We have already learned it in our our short question. And next part, we are having this hold on. Okay, now we continue. This one, the carbon dioxide is a molecule. Okay, so you are going to write it back. CO2, and of course the H2O. The most important part is this one. Okay, this sulfate, this sulfate ion, and this sulfate ion here, actually in real condition, it can be cancelled off. What's the reason? It is because this calcium sulfate, it is slightly soluble. So when it is slightly soluble, you are actually producing some of this sulfate ion as well. Okay, so in this case, we are still sticking to the frequency of collision between the calcium carbonate and the hydrogen ion. In experiment 2 is higher than experiment 1. And for the next part, the frequency of effective collision between the calcium carbonate and the hydrogen ion in experiment 2 is higher than experiment 1. Actually, if you do more questions, you will find that these questions are more or less the same. Okay, I hope you are okay with this. Okay, can no problem. So today we have already discussed until here. Now let's look at this part. The decomposition of hydrogen peroxide molecules to produce oxygen and water. Now, can you see in the diagram, they show you the manganese 4 oxide. What is the function of the manganese 4 oxide? We have already learned it in our last lesson, where it is acting as the catalyst. Okay, so now you are going to describe the experiment on how does this manganese 4 oxide affects the rate of reaction. Okay, now I need you to do this part C, as your homework. Part C as your homework. Okay, and also the structure question. You do structure question number 1 and 2. Structure question number 1 and 2, and also the essay question just now, number 7C, as your homework. Okay, any problem for our lesson today? I repeat, your homework will be the question on structure number 1 and also the essay number 7C. I will discuss all this tomorrow. Any problem? If you have no problem, we will end our lesson here today, and I will see you tomorrow. Okay? Any problem?